Nah, lucu banget, banyak itu tuh angsa bebek. Dia makan deh, takut dikejar. Tuh, lucu banget lah, angsanya lagi makan. Bebek nih, angsa. Ini ada burung gagak. Tuh, lucu dia burung gagak. Bos, ngapain bos? Bos.
Site we're on right now has been here since 1970, so we've got 50 years of observations from here. Prior to 1970, we took our measurements at the London Road campus. So and they started in 1908. So we've actually got over 100 years of continuous data set of weather observations, and we take. So there are two main types of data that we record. So there's the manual observations that you heard about in the seminar, and then there's what we call the MET-FIDUS system. So that's the meteorological field data acquisition system, and that is our sort of automatic network of weather observations that sort of encompass all the instruments on the site here. And we're going to go around and have a look at them all in a minute. And so on the other side is the manual observations that we do. There's someone from a team of volunteers will do the rounds every morning at 9 o'clock, well, between 8:15 and 9 o'clock. It takes about 4 to 5 minutes. And so involved in that is, so in addition to this field site, we have other instruments dotted about. So there's by GU01 just to the side, there's I don't know if you've seen it, the Q pattern barometer. So that's where we take our pressure readings from. And there's also an element of going up to the roof and we've got a Campbell-Stokes sunshine recorder up there, which we change the card every day. And we do visibility cloud observations and things like that from the roof. And then over here, do the rounds and try and finish bang on 9 o'clock doing the air temperature. It's kind of the sort of format we try to follow. So, probably best thing from the instrument. If you have any questions, just shout out.
Not yet. Dulu langsung forecaster apa observer juga, Jar? Sama nggak, Jar? Sama nggak ini peralatannya?
So that up there in the middle is our data room. We've got every instrument on the site has underground connections to take it to the data logging centre. And we have a Campbell C9000 data logger. That then the sort of script that takes that data, moves it onto the rack, the academic computing cluster, and from there there's a series of things that goes on. But it usually works fine. So this is our we've got a number of screens on the site which have different purposes. So this one is, I don't know if you know about Stevenson screens, but it's a kind of container designed in 1864 by Stevenson to protect sensors from direct sun, rain, and whilst at the same time allowing free flow of air. So that's the sort of explanation of the design. And in here, so these are the automatic MET-FIDUS temperature measurements that we take. So these are recording dry bulb and wet bulb air temperature every second. So you've got that gets moved across into huge files with 1 second data. And so in here we also have, there's a relative humidity sensor as well. So that's the sort of automatic side of temperature measurements. So again, this is where we take the manual temperature measurements. So we have, it's the same sort of arrangement as we've got in the automatic screen, although in this one we have manually read thermometers. So we have dry bulb and wet bulb, just the same. But we also have a maximum and minimum thermometer here, which records the max and min of the previous 24 hours. So each morning all of these are recorded, and the maximum and minimum thermometers have to be reset so that for the following 24 hours they record the correct value for that time period. So the way they work is, so the maximum thermometer, there's a constriction in the tube near the bulb end, so that when the mercury is allowed to expand up into the tube, but it's not allowed to go back. The constriction stops it, so it sticks at that maximum temperature that it reaches in the meantime. And the minimum thermometer is a similar principle, except that has there's a sort of indicator inside which is drawn towards the bulb when the temperature drops, but it doesn't go back up again once it rises. So that gives you the minimum temperature as well. So in addition to the sort of temperature measurements we take, also in this screen we've got, there's a piece tube. So this is designed to measure evaporation. So we keep that topped up with water, take a measurement every 9 AM and subtract one from the other to get the sort of amount of evaporation for that period. And there's a sort of paper disc on the bottom which soaks up the water and evaporates from that. So that gives us our evaporation, well, one of our evaporation measurements. The other one is, if you look over in the far corner, there's a sort of tank with water in. So in this, on one side of that, there's a sort of still well, which so it's free from ripples and everything, and where we take a measurement. So we use this. I don't know if you've seen one of these before. It's a hook gauge, and how this works is that sort of rests just above the surface of the water. You can adjust the micrometer here until the tip just breaks the surface exactly, yeah. And then you can read off from here exactly what the evaporation has been. The difficulty with that method is that it also you have to take into consideration precipitation. So if there's any precipitation in the previous 24 hours, it doesn't give you a sort of truly accurate measurement of evaporation. This is a sort of net effect. Underground as well. So these 3 thermometers at the front here are sort of buried to a particular depth, 5 centimetres.
Yeah.
So it gives you a profile of temperature going down through the ground. But we also go deeper than those as well. Over here, series of other thermometers down to maximum for 1 metre, and so that just kept at a constant depth. They get that every morning as well.
How about the bare soil? Does it also have this temperature at this depth?
Sorry?
The bare soil, does it also have the temperature at this depth?
Oh no, these are deeper. So you've got the those bare soil ones go down 5, 10 and 20 centimetres. So this is the instrument we use to measure visibility. So that one again operates in the infrared, and it's got a beam, and it detects the backscatter, and it determines what the visible range is. So the quantity that it gives us is the meteorological optical range, and that sort of is your sort of proxy for visibility, and it gives you a distance in kilometres basically about how far you can see. And this instrument also, as well as that, it does a number of other things. It can the sort of the angled beams can detect hydrometeors in the atmosphere, sort of between them, and it can use the backscatter properties to determine what kind of precipitation they are. It can also determine the rate of precipitation as well. So that gives you a lot more information about precipitation events.